welcome to the fifth proof video in this series. In this video, we are going to prove the isosceles triangle theorem. If you remember, this is one we talked about in class a few days ago, but we had said that we were going to need to wait to prove it because we didn't have all the skills that we needed yet to really create a good proof for this. But now we have those skills, so we're going to go ahead and prove that. Just remember the isosceles triangle theorem. Also, it can be known as the base angle theorem. It states that if two sides of a triangle are congruent, then the angles opposite of the sides are congruent. So we are given triangle ABC as an isosceles triangle with line segment BA being congruent to CA. So I am going to go ahead and mark that BA is congruent to CA. And we're trying to prove that angle 1 and angle 2 are going to be congruent. So, like most of our proofs, we're going to start out with what we are given. Now we are given that ABC is an isosceles triangle with segment BA being congruent to segment CA. But if you look at the drawing, we are also given this important information that angle 6, because of that box, is a right angle. So we're going to include that in the given, even though it wasn't something that was necessarily typed out here. It was something that we could gather from the diagram. If it's given to us in the diagram and it's clearly marked, we can use it. We can't assume anything from this though, so anything that's not marked we cannot use. Just a reminder on that. Our reason for this is going to be given. So right now we need to focus again on proving our two different triangles that we have in here are going to be congruent. So I'm going to start out by looking at one of the things that is the most obvious to me, and that is going to be that AQ is going to be congruent to AQ by the by the reflexive property of congruence. I'm thinking back to what we're trying to prove there. So that is going to be due to the reflexive property of congruence. Now I also can tell a little bit more from the fact that that angle right there, angle 6, is going to be a 90-degree angle. Because that makes a 90-degree angle, we are going to be able to say that angle 5 is also a right angle, and that A and Q are going to be perpendicular to BC. And that is by the definition of perpendicular lines. So I can go ahead and actually mark angle 5 here as well. So at this point, I have a side, and then I know these are both 90-degree angles. Now we know that if we have two right angles, that they're going to be congruent by the right angle congruence theorem. This is one that we proved about a week ago in class. So since these are both 90-degree angles, they're both right angles, they're going to be congruent. So we now have an angle that is going to be proven right. Specifically, and this is the important part here, this is going to be a right angle. And that's going to allow us to do something that we're normally not able to do. Alright, so because that is a right angle, and only because it is a right angle, if we didn't have a right angle, this wouldn't work. We can say that these triangles are going to be congruent, BAQ and CAQ, because of the right angle side-side theorem. If you remember when we were talking about this on our 5 ways to prove, we had something called hypotenuse leg. This is a slight variation of the hypotenuse leg, and that's going to be the right angle side-side theorem. So, when we come down to our last step, because these are congruent triangles, these are going to be having corresponding parts congruent. So we have our angle 1 congruent to angle 2, just like we were looking for, and that is by congruent parts of congruent triangles are congruent. All right. So that wraps up this proof video. We have now proven the isosceles triangle theorem that if two sides of a triangle are congruent, then the angles opposite of the sides are congruent. This is now fair game to use in any other proofs that we were doing. And we've got a couple more proof videos for you to check out. So we'll see you then.